I am R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we are going to see the topic log periodic antenna. So, the log periodic antenna is simply referred as LPDA, that is log periodic dipole array. It is a wideband directional antenna that provides gain and directivity combined over a wide range of frequencies. A log periodic antenna is that whose impedance is a logarithmically periodic function of frequency. And the geometry of the log periodic antenna is so chosen that its electrical properties must repeat periodically with the logarithmic of the frequency. The frequency range in which log periodic antenna operate is around 30 MHz to 3 GHz, which belongs to very high frequency and ultra high frequency bands. And this is the structure of log periodic antenna. It is a log periodic dipole array consists of number of dipoles formed in an array, and these dipoles progressively reduce in size from the back to the front. The direction of maximum radiation is from the smaller front. And there are different regions in log periodic antenna. The active region, the sections of the antenna that are contributing to the transmission or reception vary with frequency, and only about 3 may really contribute to the radiation at any given frequency. So there is also a smooth transition of the active region of the LPDA along the array as the frequency of operation ranges. Each dipole element of the LPDA is fed, but the phase is reversed between adjacent dipole elements. This ensures that the signal phasing is correct between the different elements. So it also means that a feeder is required along the length of the antenna. Normally, this is arranged so that it forms part of the mechanical structure of the array. So when the signal meets the first elements on the antenna, that is those closest to the front that are the smallest, it will be found that they are spaced close together in terms of the operating wavelength. As the feeder sense is reversed between the elements, the fields from these elements will tend to cancel out and no radiation will occur from these elements. As the RF signal travels along the feeder in the antenna, it reaches a point where the feeder reversal and the distance between the elements gives a total phase shift of about 360 degrees. At this point, the effect which is seen that of the two phased dipoles, the signals from adjacent dipoles are in phase. So the region in which this occurs is called the active region of the log periodic antenna, and the remaining two regions left and right are inactive regions where the dipoles lengths are lesser and greater than lambda by 2. So although the example of only two dipoles is given, in reality the active region can consist of more elements. It may be 3 or more. The actual number depends upon the angle alpha and a design constant. So behind the active region, the signal again falls out of phase and no radiation occurs. The elements outside the active region receives little directive power. So a log periodic dipole array design equations, it consists of a sequence of side by side parallel linear dipole forming coplanar array. Its design equation is Ln plus 1 by Ln is equal to Rn plus 1 by Rn is equal to Sn plus 1 by Sn is equal to Dn plus 1 by Dn is equal to An plus 1 by An is equal to 1 by tau. So here n is the number of dipoles 1, 2, 3 up to n. So An is gap spacing at dipole centers, and the another parameter in the design equation a spacing factor sigma, and it is defined as Rn plus 1 by 2ln minus Rn plus 1 minus Rn by 2ln. It is equal to Sn by 2ln. So here Rn is the distance of dipole from the origin. The dipole length increases along the antenna so that the included angle alpha is constant and the length L and spacing S of adjacent elements are scaled so that Ln plus 1 by Ln is equal to Sn plus 1 by Sn is equal to K is equal to 1 by tau. So here K is the constant and alpha is the apex angle, K is the scale factor. The formulas are tan alpha by 2 is equal to 1 minus 1 by K divided by 4 into S by lambda, and the apex angle alpha is equal to 2 tan inverse of 1 minus tau divided by 4 sigma. And another design equations, Ln plus 1 by L1 is equal to K squared is equal to F, and F is the frequency ratio or bandwidth, and here for 5 element dipole array K is equal to 1.19 and the frequency range ratio is F is equal to 2:1. The elements 5 is twice the length of the element 1. The design of LPDA involves the determination of the spacing factor sigma and the scale factor 1 by K. The spacing factor gives the successive dipole spacing and the scale factor determines the length of the successive dipoles forming a wedge-shaped cone. So the advantages: the antenna design is compact, gain and radiation pattern are varied according to the requirements. Disadvantages of log periodic dipole array is external mount, installation cost is higher. Applications: they are used for high frequency communications and used for particular sort of TV receptions, used for all round monitoring in high frequency bands. So now the assessment: log periodic antenna uses which range of frequencies? We know the answer is A, it is VHF and UHF. And the second question: which of the following best suits to describe the impedance of a log periodic antenna? The answer is it is the function of logarithmic of frequency, so that it is called as log periodic antenna. Thank you.